So in this session, we will go through the answer for the questions that we discussed in the last session. Let's go through the first question. What is normalization and how does it differ from denormalization? So normalization refers to organizing a database column, row and tables to minimize data redundancy. We commonly use it in online transactional processing or OLTP, where large tables divide into smaller ones with which define the relationship for clarity. Here relationship means one-to-one, one-to-many. Tables with frequent updates mostly use normalized form. Now let's make it short. Normalization mainly used to minimize data redundancy, and the database, mostly source database, which are having frequent updates, mostly use normalized form. Now let's move to denormalization. This optimizes data performance by clustering data and adding redundant data. We can also say denormalization is the process of trying to improve the read performance of a database by adding extra attribute to an existing table, adding new table with existing attribute, or even creating instance of existing table. We use it in online analytical processing or OLAP system. Tables used for analysis and reporting purpose mostly use denormalized form. Now let's make it short. Denormalization maximizing data redundancy, and the reason behind this is to improve the read performance of the database. That is the reason extra attributes it add to the existing table, or it create a new table with all the existing attribute, or even create instance of the existing table. And the database mostly used for analysis or reporting purposes. We can say target DB or OLAP use denormalized form. Now let's move to the second question. What are the various types of normalization levels or normalization forms? So we have 1NF, 2NF, 3NF, BCNF, 4NF and 5NF. The third question. What are the keys in normalization? In normalization, there are three main keys. There are primary key, which we call PK, foreign key, which we call FK, and unique key, which we call UK. We use the PK to identify each unique row in a table, these allowing null or non-existing values. The FK is for column with value based on the PK value from other tables. PK and FK like parent-child relationship. So in my upcoming video, I will give a walkthrough about the referential integrity, where we can cover the PK, FK parent-child relationship. And the UK identifies every row as unique and allows null value. Let's go through the fourth question. What are the advantages of normalization? There are many advantages to use normalization, but based on experience, we can say there are three primary ones. The first one, normalization is effective at eliminating duplicate records and entries. Doing this helps to save critical storage space in the database, which is another big advantage. Finally, it creates better query performance and makes query easier to maintain. Now let's move to the fifth question. What are the differences between 1NF and 2NF, 2NF and 3NF, etc.? So please refer to my previous video for this concept. In this concept, we can clearly identify differences, but for reference, I have given few differences. We could find many differences, but the main important and highlighted differences I have mentioned here. Now the difference between 4NF and 5NF. For a relation to be in 4NF, it must be in 3NF. For a relation to be in 5NF, it must be in 4NF. A relation in 4NF must not have multi-value dependency. A relation in 5NF must not have any joint dependency. Now the difference between 3NF and BCNF. For a relation to be in 3NF, it must be in 1NF and 2NF. For a relation to be in BCNF, it must be in 1NF, 2NF and 3NF. The redundancy is high in 3NF. The redundancy is comparatively low in BCNF. It is comparatively easier to achieve. It is difficult to achieve because it cut redundancy. That's the reason. To most of the extent, that's the reason it is difficult to achieve. 3NF can be obtained without sacrificing all dependency. All the functional dependency of 3NF we can find in 1NF and 2NF. Dependency may not be preserved in BCNF. There may